All right, today we got geometric sequences. We just got finished working on arithmetic sequences. Now we got geometric. A geometric sequence is when you, instead of adding the same difference every time, we're going to multiply by the same number every time to get our next number. And what we're multiplying by is called R, stands for ratio, common ratio. Here's the book definition. Geometric sequence is in that form. And if you look at it, basically raising R to the next power. A times R squared. Remember, A is the first term. R is the common ratio, and the nth term, there's the big formula right there. The term you're looking for, the last term, is the first term times R to the n minus 1 power. And here's an example of a geometric sequence down here. Notice they're multiplying by -5. Sorry about that. That should be 5 right there. Sorry about that. We're multiplying by -2. 5, -10, 20, -40, 80. The R there would be -2. That's what they're multiplying by. Little tip here, anytime you need to know R, and you're going to need to know that because that's in that formula, you can always do it by putting the second term. I should do this. Second term over the first term, or you could do the third term over the second term. As long as you put one term over the previous term, that's going to tell you what R is. And I'll show you that as we go on. Okay, this one says find the 8th term of the sequence. Okay, so I'm using the formula you just saw on the last slide. I'm going to do if I'm the 8th term, I'm going to take the first term times R. R in this case is 3, and you can tell that by putting the second term over the first, which is 3, to the n minus 1 power. 8 is my n, so I'm going to do the 7th power. So I'm just going to take my calculator and punch that in. 5 times 3 to the 7th power, and I'm getting 10,935. Look how fast they grow. The geometric ones really grow really fast because you're multiplying terms instead of just adding the terms. This one says the third term of a sequence is 63, so that means I should have kept that. A3 would be R squared, and it says the 6th term is 1702. That's A times R to the 5th. Now, the third term is what's 63 over 4. So 63 over 4 is A R squared. The 6th term is 1701 over 32, and that's A R to the 5th. Now, a couple ways you can solve this. I'm gonna use substitution. I'm gonna divide right here by R squared. So that's what my A is. That's my first term. So I'm gonna plug that in to this other side. I'm gonna say 1701 over 32 equals 63/4 over R squared times R to the 5th. And what happens is the R's cancel each other. So over here now really just have R cubed. So what I'm going to do is I'm going to divide both sides by the 63/4. Think about this a second. If you divide by 63/4, you're really multiplying by the reciprocal, which is 4 over 63. And if you do that, 4 goes into 32 8 times. I believe, I'm touching my calculator, I think that 63 is going to go into 1701 also, and it does 27 times. So that gives me R cubed is 27 over 8, which means my R, if I take the cube root of 27 is 3, the cube root of 8 is 2. There's my R. Now that's not the answer because it said find the 5th term, but now I can find the 5th term easily. One little trick here I can do is, like, if you notice right here, A3 equals A times R squared. A6 is A times R5. All right, so if I'm going to look for the 5th term, A5, what I can do is I can use any term I want to find that. And because I know the 3rd term, I'm going to do the 3rd term times R squared. Here's the deal. Whenever these two numbers add up to be that one, you're good to go. So here it goes. The 5th term is going to be the 3rd term, which was 63 over 4, times R squared. R is 3/2, and I'm going to square it. So I'm just going to punch that directly in my calculator. 63/4 times 3/2 squared. And hit math frac. I want a fraction answer if it would give it to me. And it does. It gives me 567 over 16. That's quite a bit of work on that one. Hope that makes some sense. I need to watch that slide one more time. All right, we can also find sums of geometric sequence. Notice this says partial sums. Like you can find the sum of the first 5 terms, the first 8 terms, first 7 terms. Here's the formula we're going to use. And the formula for the sum is the first term times 1 minus r to the n power, n being how many numbers there are, and then over 1 minus r. All there is to it. Let's try a couple here. First one says find the sum of the first 5 terms of this one. So again, that formula was the first term, which is 1, times, I'm going to put the 1 in parentheses, probably easier, 1 minus r to the n. R, remember, is the second term over the first. That's just 0.7. So I'm going to do 1 minus 0.7, n is 5, to the 5th power over 1 minus 0.7. And I'm going to punch that directly in. I'm putting the whole numerator in parentheses, and you should too. You might want to punch this with me to make sure you're good. This may be the hardest thing today, is just putting this in a parenthesis, putting this in your calculator. Quite a few steps here. Divided by 1 minus 0.7, punch that in, and I'm getting 2.7731. And I'm going to leave that as a decimal, only because they gave me decimals there. So if they give you decimals, feel free to leave your answer as a decimal, and that's fine. But basically just knowing that formula, plugging the numbers in, making sure you know how to use your calculator, and that's a big deal. All right, find that sum. And this is geometric. Remember, to find the first term, you put 1 in there. So the first term is going to be 7 times negative 2/3, which is negative 14/3. To find the second term, I would put a 2 in there. Now, when you put a 2 in here, you're going to get, that's going to turn this into 4 ninths. Okay, so 7 times 4 ninths is 28 ninths. And so then it's going to keep on going. It's going to be 5 of them. So sum of the first 5, sum of the first 5 is the first term, which is the negative 14/3. That sits out here. Times the fraction, which is going to be 1 minus r. Now, that's the r. That's what they're multiplying by. So I'm going to say 1 minus negative 2/3 to the 5th power over 1 minus negative 2/3. Got to be so careful how you punch this in. I'm going to leave this out here for a second, this negative 14/3. I'm going to just do I'm not going to read the fraction bar. I'm just going to type in that fraction only. So on my calculator, I'm hitting open parentheses, 1 minus, open another one, just like you see it on the screen, to the 5th power, close the top, divided by, on the bottom, opening another one, 1 minus, open, negative 2/3. Tons of parentheses. Close the whole bottom, hit enter. I'm going to change it to a fraction. And so I get this. When I type in that whole fraction, I got 55 over 81. And now I've got to multiply those two. So I'm on my calculator again, open negative 14/3 times 55 over 81. A bunch of parentheses again. I'm going math fraction, and I get this for my final answer, the final sum, negative 770 over 243. That's 770. Guys, I'm telling you, I know you're just sitting there watching this video. It would really help you to punch that in your calculator and make sure you're getting exactly how I'm doing those steps. I'm having to put the whole numerator in parentheses, the whole denominator in parentheses. It would help you to practice. Also, make sure you understand where those first 2 numbers came from that I got in that problem. All right, this is awesome right here. It's kind of weird when you think about it. This is sum of an infinite geometric series. That sounds strange. That's a series where it goes forever. Like, how can you find the sum of something that goes forever? I'll show you real quick, but you only can do that if this is true. That's a big deal. If the absolute value of r is less than 1, then you can do this. If it's bigger than 1, we call it diverges, which means you can't do it. You can only do it if the sum converges, which means r is less than 1. Or technically, r is between negative 1 and positive 1. Let me show you how this works real quick. If I have 1 plus a half plus a fourth plus an eighth plus a 16th, now that's geometric because they're multiplying by a half. And the key is they're multiplying by a half, which is less than 1. Okay, if I start adding those numbers together, I'm going to go through this really quick. If I add the first 2, it's 1.5. If I bring down the fourth, that's 1 3/4. If I bring down the eighth, you get 1 7/8. I'm adding here a 1 15/16, a 1 31 over 32. And if you look at those numbers, they're getting closer and closer to 2. All right, closer and closer to 2. They're converging on 2. So we're going to say, okay, it has that sum. But again, this only works because r is a half. R is less than 1. And again, how do you find r? Second term over first term. There's your formula. That's what we're going to use for an infinite geometric series. It's got to be that formula. It's got to be infinite. And r is got to be less than 1. I'm going to show you one example and we're done. All right. It says determine whether infinite geometric series is convergent or divergent. If it's convergent, find the sum. Okay, so this part A, you got to find r. If I find r, I'm going to put second term over first term. 2/5 divided by 2 is really 2/5 times the reciprocal, which is 1/2. Guys, that's 1/5. And because that's less than 1, that means it's convergent, which means I can find the sum. So I'm going to go the sum, the infinite sum, is the first term, 2 over 1 minus r. That's just the simplest formula of the day. 1 minus 1/5 is 4/5. If I do 2 times the reciprocal, I'm going to get 5/2. And guys, that's the sum. Not too bad. Now the second one, this second problem, let me change colors here. I got to find r, and I would go 7/5 over 1. Guys, that r is 7/5. And because it's bigger than 1, that means it's divergent. It doesn't converge at all, which means you cannot find the infinite sum. Okay, so to be honest, sometimes you're cheering for divergent because it saves you any work. You can just stop. This is only the case on infinite sequences, though, or series, so be careful. All right, hope that made some sense. Hope you practice the calculator. See you in class tomorrow. See you, bye.